Hi guys, let's do binary tree zigzag level order traversal. So we're given the root of a binary tree and they want us to return the zigzag level order traversal of its nodes values. So from left to right, then right to left for the next level and alternate between. So in example 1, we're given this tree and then they want us to return this list where we have like 3 and then 20 and 9 and then 15 and 7. So as we can see it, we do this in the order of like zigzagging through the tree. So like from 3 down this way and then down this way. In example 2, we're just given one singular node, so we just return 1. In example 3, we have an empty tree where the root is null, so we just return an empty list. So for this one, since we're going level by level, it's going to be a BFS traversal, but there's going to be a little bit of a twist since we are doing a zigzag order instead of just straight left to right as we usually do. So we're going to have to keep track of what level we're at in the tree. And if you notice the even levels, we're going left to right. And as you can see, 3 is just a node by itself, but like 15 and 7, this is if this is level 0, level 1, level 2, then level 2, like 0 and 2 technically are like left to right, and then the odd levels are going right to left. So we'll keep track of what level we're at, and then we'll just check if it's odd or even, and go add them to our list based on that order. Based on that level. Then we'll change the order of it. So first our base case is if the root is null, then we'll just return an empty list. So let's do that. Okay, and then we're just going to set up our queue and our list for BFS and to return our output. So and then we'll add our root into we'll add our root into our queue to start our traversal. So I'll show you how this works as I go. So we start out with an empty list. We start out with our queue that only has our root in it, which is 3, if we're going off of example 1. And so then we can say while our queue is not empty, then we will go through our BFS. And up here, I'm actually also going to initialize our variable for to track what level we're at in the BFS traversal, like in the tree. So we start this off at 0, and then while our queue is not empty, then we are going to iterate through. So our nodes in current level is queue.size. This is all standard for BFS. And then we need to set up an array list as well to add to our list in here. So because as you can see, we have like a list of lists. So we need to have a new list for every level. So we're going to do that in here. So, and then we're going to add like the values into this array list to add to this list. So we can also have like another one for like current level. Okay, and then now we're going to loop through our nodes in each level. So and then so this is 1 because we have 1 node currently, and then we will remove that node. So then we'll remove the 3 and store it in this variable node. And then we're going to add the value of our current node into our array list. So we will add that into here. Then now we want to add the children into the queue. So if node.left is not null, queue.add node.left, and same thing for node.right. Okay, so we will add this node's children, so 9 and 20, into our queue, since that's node.left and node.right. And then we, after our loop here, so once we've gone through this entire level, then we're going to want to check if our current level was an even or odd odd level. So if level mod 2 is 1, that means it's odd. Then we're going to reverse that list. So currently it's even, so we're not going to do this. But if it's odd, then we would reverse it. And I'll show you guys what that would look like later. So then we're going to add that to our list, like this entire list into our list. So we are going to add that basically, and then we will increment our level for the next iteration. And then once we do all of this, then at the end we're going to return our list. So let's walk through the rest of it just to see how this would look. So then the nodes in our current level now is 2. And then we have a new array list for our current level, so that's empty now. And then we're going to loop through twice for each node in here. So we're going to take off the top node, which is 9. Then we are going to add this to our array list. And then if node.left is not null, then we would add that, but there's nothing here, so we don't do that. And then for node.right, it's null, so we don't do anything here. And then our next iteration, we're visiting our next node. Forgot to remove that, sorry. Then this becomes 20, because that's our next node, and then we remove that. Then we're going to add this to our array list. And then if node.left is not null, which it's not, then we will add that to our queue, so 15. And then same for node.right, which is 7, so we add that. And then we are done with this loop. So then we're going to check, then we're going to exit that loop. We're going to come down here. If level mod 2 is 1, which it is because now we are on level 1. Because we incremented level down here. So let's say level is 1. Then, so 1 mod 2 is 1. So we will reverse this. So this would become 20, 9. And then we're going to add that to current level. So, or we're going to add current level to list, sorry. So we would add this into list, just like that. And then level plus plus. So now we're on level 2. And then when we come back up here, our nodes in current level is still 2 because we have 2 nodes in our queue. Our current level is a new array list, so this gets wiped out. And then we are looping through twice here. Our top node is 15, so we would remove that and store it in here. Then we are going to add that to our array list, which is here, so 15. Node.left is null, so we add nothing. Node.right is null, so we add nothing. And then our next iteration, then this becomes 7, because that's the next node in our queue, and then this gets removed. And then we're going to add that into our current level. Then node.left is null, so we do nothing. Same with node.right. If level mod 2 is 1, well, now level is 2. So this is even, so we don't do anything. And then we're going to add this to our list. So, oopsie, just like this. So then now our queue is empty, so we exit this loop, which is down here. And then we're going to return list, which is this. So that's what we would return. And then as we can see here, that is exactly the output that we want. So let's submit that. Okay, and then time complexity is O of n, where n is the number of nodes in the tree. And that's because we are still just visiting every node once in this algorithm. So in our BFS, right, so we're visiting every node level by level, one by one for each level, but which we can see that we're doing in this while loop. And then our space complexity is, so again, O of W or O of n. And that is because, again, so the maximum number of nodes we're going to store in our queue at any one point is the widest point of the tree, which is usually the bottom of the tree, or O of n, because the maximum number of nodes that can be in the bottom level is n over 2, which simplifies to O of n. And as we can see, so we would store them in the queue here if that was the case. And then we're storing the same amount of nodes in the list, like it's still O of n. So I guess actually we could just say O of n here for this one because we're storing all of our nodes in the list. So I think O of n is probably better. And yeah, those are our only data structures here. So that was it for this problem. Please like and subscribe if you found this helpful. Bye.